important topics in radiological physics, X-ray absorption and scattering, including the half-value layer and 10th value layer concepts. Let's begin. Slide 1, Absorption of X-rays. X-rays are highly penetrating rays. How much they pass through a material depends on the atomic number, or Z value, and the energy of the beam. As X-rays move through a material, part of their energy is absorbed, following the exponential law. I equals I naught times e to the power minus mu x. This means intensity decreases exponentially as thickness increases. Slide 2, Practical absorption. In real conditions, X-rays are not monoenergetic. They contain photons of different energies. As the beam passes through matter, the softer low-energy photons are absorbed faster, while the harder, high-energy photons continue to pass through. This process makes the beam more penetrating, or harder, as it travels through thicker material. Slide 3, Quality of an X-ray beam. The quality of an X-ray beam means how penetrating it is. If we plot beam intensity against absorber thickness on a semi-logarithmic scale, a monoenergetic beam gives a straight line, but for a polyenergetic beam, the curve bends because low-energy photons are removed more quickly. This effect shows how beam quality improves with selective absorption. Slide 4, Half-value layer, HVL. The half-value layer, or HVL, is the thickness of material that reduces the X-ray beam's intensity to 1/2 of its original value. Mathematically, HVL equals 0.693 divided by mu, the linear attenuation coefficient. A higher HVL means a more penetrating higher energy beam. That's why HVL is a key measure of X-ray beam quality. Slide 5, Effective filtration. Adding filters to the X-ray tube removes low-energy photons that don't contribute to image formation, but increase patient dose. As filtration increases, HVL also increases, making the beam harder. However, once most of the low-energy photons are removed, additional filters make very little difference. Slide 6, 10th value layer, TVL or TVT. The 10th value layer, or TVL, is the thickness of material that reduces the X-ray intensity to 1/10 of its original value. 1 TVL is roughly equal to 3.33 HVLs. TVL is commonly used in radiation shielding and protection design, especially in hospitals and laboratories. Slide 7, Scattering of X-rays. When X-rays strike matter, not all of them pass straight through. Some are deflected in different directions. This is called scattering. Scattered radiation causes image fog and can increase exposure to surrounding areas. Scattering depends on the material, the angle of incidence, the beam's energy, and the volume of the object. Slide 8, Secondary X-rays. Along with scattering, atoms in the material can emit secondary or characteristic X-rays. These occur when the incoming X-ray knocks out inner shell electrons and outer electrons fall in to fill the gap, releasing characteristic radiation. The energy of these secondary X-rays depends on the material itself. Conclusion. Let's summarize what we've learned today. X-ray absorption follows an exponential law. HVL and TVL define the quality and strength of an X-ray beam. Filtration removes soft rays and hardens the beam. Scattering and secondary radiation occur when X-rays interact with matter. Understanding these principles is vital for safe and effective imaging. Thanks for watching. If you found this video helpful, please like, share, and subscribe to GN Physics Tutorials.